And now, welcome to probability and combinations. Our first example, how many combinations of cars can you make with the 3 lanes? So we had the yellow sports car, the green minivan, and the old light green car. So then I could have the SUV come first, and then the sports car, and then the light green car could still be there. Or I could have the yellow car come last, and the SUV come second, and the light car come first. Or I could do the yellow car, the light green car, the SUV. I could do the SUV, the light green car, then the yellow car. Let's see, I could do the light green car starting it off again. And it could be followed by the yellow sports car, and then the green SUV. And so each one of these is a different order. And that kind of took me some time to do, and so we have other strategies to mimic this, so let's look. Let's say I was planning a meal, and I could pick an item from each one of these columns. Another way we could do this is called a probability tree. And so I would start off with, I could have chicken, beef, or fish, and I'm abbreviating to save myself some space. If I chose chicken, I could have Coke to drink or water. And if I had chicken and Coke, then I could have pie, cake, ice cream, or fruit. If I had chicken, water, pie, cake, ice cream, or fruit. If I chose beef, I could have Coke or water, and then from each one of those, I could pick from pies, cakes, ice cream, or fruit. And the same for fish. Okay, and so once I get all my pieces written out, and sorry, it's starting to get difficult. I'm running out of space to write. All right, so now I count my end column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 choices, different choices I can make. Now let's look at this. I had 3 choices for meat, 2 for drinks, and 4 for desserts. Is there some sort of math operation that I could use with these numbers to get this answer? Take a moment and see. Well, if I added them, 3 plus 5, 3 plus 2 is 5, plus 4 is 9. No. If I subtracted 3 minus 1, 3 minus 2 is 1, minus 4 is negative 3. Dividing 3 divided by 2, oh, now I'm dealing with 1.5, very messy. Divided by 4 is 3/8, yikes. So 3 times 2 is 6 times 4. Oh, 3 times 2 times 4 is 24. That's another way we could have done that. Let's keep that in mind. So what you can do is do a line for each type of outcome, and then you can multiply. So if I'm making an outfit with shirts and tops, I have 1, 2, 3, 4 shirts that I can pick, and I have 1, 2, 3 pairs of pants. So 4 times 3 is 12. There are 12 different outfits I could make. I could do the blue shirt with the polka dots or with the stripes or with the blue pants, and that's 3 outfits, and then another 3 outfits with the green shirt with each of the pants, and then another one with the red shirt and another one with the green shirt. But wasn't it faster to just write my math problem? Okay, 6 different color balls were placed in a box. If 3 out of the 6 balls were chosen out of the box, how many possible combinations could there be? So I drew 3 lines because I'm only picking 3 out. Okay, when I first reach into the box, how many colored balls can I pull out? There are 6. So let's say I happen to pull out, let's say I happen to pull out a yellow one. So I no longer have 6 in there anymore. I now have 5. And then if I reach in and I pull out, let's say, a green one, I no longer have 5. Now I have 4 because I didn't put the balls back into the box. So 6 times 5 is 30 times 4 is 120 different options. Okay, another one. So you think it's really easy to pick a lock. Elroy has 5-digit locker combination. Now you're lucky because your locker combination only has 3. But he has 5 digits to remember, and boy, sometimes we can't remember the 3. He knows that the first digit is 2, so I'm going to go ahead and fill this in. If this is 2, I only have one option. I don't write 2 there. I write the number of options. I only have one option, and that's the number 2. And the last digit is 1, so we only have one option for the last digit. Now he has to figure out these other digits here. Now, the digits may be repeated. And we're going to make this a little bit easier. We're going to say the combination only has the digits 0 to 9. Okay? Now, how many digits is that? Many of you will say 9 digits, but let's write it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different digits. So if my locker combination, if the next number was 3, and digits may be repeated, couldn't this next number also be a 3? It could. So I still have 10 numbers to pick from. And for this one, I still have 10 numbers to pick from. 1 times 10 is 10. 10 times 10 is 100, because you remember when you multiply by multiples of 10, you just slap on that 0. It's that whole place value thing. 100 times 10 is 1,000, and anything times 1 keeps the same. So we have 1,000 different combinations. So I think he'd be standing at that locker for a while trying to bust that locker open. Okay, my favorite one. We're running a race. Okay, so we have Jack, Ann, Jerome, Mina, Juan, and Tina. They're all on that starting line right here getting ready to start that race. And when they line up and that gun goes off, how many people could win the race at the start when they're on that line? We don't necessarily know who's going to win. So 6 people have a chance. All right, well, Mina, she finished first. So Mina's out of the running. She won. So now we're trying to figure out who finishes second. So we have Jack, Ann, Jerome, Juan, and Tina still left. So we have 5 people competing for second. Okay, Jerome finished second. So let's get Jerome out of there. Okay, so now we have Jack, Ann, Juan, or Tina to finish. We have 4 people that could finish third. And Juan finished third. So now we have Jack, Ann, or Tina that could finish in the 4th position. So that's 3 people. And Tina slid through for 4th place. Okay, now we have 2 people left, Jack and Ann. And Ann finishes. And so then that means Jack is going to finish in last, so only one option for the last place. So 6 times 5 is 30, and I write it here to keep track for myself. 30 times 4, well, 3 times 4 is 12. Power of 10, add that 0. 12 times 3 is 36. Power of 10, add that 0. If I have 2 sets of 36, I have 72. Bring down that 0. And 720 times 1 is 720. Let's see if we got it right. And yes, we did, 720. So you have 2 strategies. You can go ahead and you can make your not your factor tree, but your probability outcome trees. Or you can look at the situation, determine how many different endings could happen. So if it's a 3-digit locker combination, I have 3 endings. And then you write your option, how many choices you have for each location. Be careful, though, because if something can't repeat, for instance, in this last problem, if Mina won, she can't get 2nd, 3rd, 4th, and 5th. She already took 1st place. So remember, if it can't repeat, that you have to reduce how many options you have for the next place. Good luck with probability outcomes.